All right, guys, before we get started, questions over the homework. Questions over any of the homework assignments. What we're doing today and what we're continuing to work on is solving logarithmic equations. And we solve logarithmic equations, especially if we have a number outside of a log like this here. We need one term on both sides. We need to get one logarithmic term on one side, everything else on the other. Now here, for this one here, we do have two logarithmic terms. We have log of 2x and we have log of x minus 5. Now luckily we can rewrite this as a single log according to our product property. Product property says if we have two things being multiplied inside the log, we can rewrite it as a sum of logs. Or if we have two logs with the same base being added together, we can rewrite it as a single log with what's inside being multiplied together. Now because these two logs have the same base, we can rewrite them as a single log with what's inside being multiplied together. So our log of 2x and log of x minus 5 can be rewritten as log of 2x times x minus 5. Because for us to be able to use the steps that we did on Friday, or really Thursday, to work this out, we need one log. So being able to rewrite log of 2x plus log of x minus 5 as log of 2x times x minus 5 makes this a whole lot nicer to work with. Questions on this first part? Now, our second step was to get the variables out of the logarithms. And to do that, we're going to put it both sides to the base of the log. Since log, our log, does not have a written base, it's not stated, it's understood to be 10. So we're going to put both sides to the base of 10 because 10 to the log base 10 is going to simplify out, is going to reduce out, leaving us with 2x times x minus 5. And the right-hand side is just going to be 10 squared. Now at this point here, we can leave it as 10 squared. We could rewrite it as 100. Either way works. For the time being, I'm going to leave it as 10 squared. Questions on this here? Now we do have some multiplying and simplifying to do before we can really start our solving process. On the left-hand side, we're going to have to distribute that 2x and x minus 5. 2x times x is going to be 2x squared. 2x times negative 5 is going to be negative 10x. And 10 squared is going to be 100. Now, unlike Thursday, where most of the equations we had, we didn't have an x squared term. We got x by itself, we solved. Here, we do have an x squared term. We have this quadratic term. We need to get the equation equal to 0 to be able to solve from there. And luckily for us, we only have to really do one thing to get this equation equal to 0, which is going to be to subtract 100 from both sides. 2x squared negative 10x minus 100 is equal to 0. No like term, so we just move it over to the other side. Questions on any of these here? Now we need to solve 2x squared minus 10x minus 100. Whenever we're doing solving these quadratics, the first thing we should really be looking for is greatest common factor. Because even if it doesn't factor, it's going to make things nicer in the long run. And looking at this here, 2 10, and 100 do all have a greatest common factor of 2. So if we factor it out, we divide it out of every single term, 2x squared is going to become x squared. Negative 10x is going to become negative 5x. Negative 100 is going to become negative 50. Now, if we want to factor it, we'll have our 2 sets of parentheses with 3 spaces. Now we're going to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here our third term, negative 50, is negative, so our signs are opposite. One's going to be positive, one's going to be negative. Next is finding the factors of the first and third terms. Well, our first term is x squared, so the only factors are x and x. Factors of the third term, factors of 50. 1 and 50. 2 and 25. 3 is not a factor of 50, but we do have 5 and 10. And really, that's going to be it. Those are the only factors of 50 that we have. Which one do we want to try first? 5 and 10. We could have tried x plus 5 or x plus 10 times x minus 5, but I noticed that the middle term is negative, so I want the bigger number, hopefully, to be the negative term. And we can check and make sure we do get that middle term of negative 5x. X times negative 10, negative 10x. 5 times x, positive 5 times x, positive 5x. And negative 10x plus 5x, negative 10 plus 5, would give us the negative 5 middle term that we need. And as a reminder, we don't check every single term because our x times x is indeed x squared. 5 times negative 10 is negative 50. Factors of the first and third term. Questions on any of this here? We do have 2 or more things multiplied together to equal 0. So according to the zero product property, one of these has to be 0. And our only 2 choices that we have are the x plus 5 and x minus 10. 2 we can't do anything with. We can't plug anything into it. So we're just focused on these 2 here. And now we just need to solve. For our x plus 5, we would subtract 5, telling us x is negative 5. For x minus 10, we would need to add 10, telling us x is equal to 10. So negative 5 and 10. Questions on those here? Now with these here, we do need to make sure we check our solutions and make sure that they do indeed work. So I'm going to check 10 first. So we're going to check x equals 10. So we're going to have log of 2 times 10 plus log of 10 minus 5. And it's supposed to equal 2. Log of 2 times 10, that's log of 20, plus log of 5. Now, for the most part, just knowing what log of 20 and what log of 5 is might not have off the top of our head, but we can grab the calculator and say log of 20 plus log of 5, and it will tell us it is indeed 2. So 2 is indeed equal to 2. So we're good there. You can write it down below it. I'm just going to erase and do this again. Because we also need to do this for when x is equal to -5. And we'd have log of 2 times -5 plus log of -5 minus 5. And again, this should equal 2. Now log of 2 times -5, or 2 times -5, would be -10. And -5 minus -5 would also be -10. We cannot take log of a negative number. And because when x is -5 made what's inside these logarithms negative, it does not work. So we have to throw out x equals -5. It is not a solution because it causes what's inside the log when we plug it back in to eventually be negative. I can't take log of -10. Doesn't have a value, doesn't work. Questions on this here? We ready for the next one? Log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. Again, want one log on one side, everything else on the other. Since I have two logarithms with the same base being added together, we can rewrite it as a single log with what's inside being multiplied. Now I could put the parentheses around that 6x, it would not be wrong, but these are the same. Now that I do have one term on both sides, we need to get that variable out of the logarithm, and we can do that by putting both sides to the base of what? 6, because the logarithm's base is 6. And 6 to log base 6 is going to simplify out, leaving us with 6x times x minus 1 is equal to 6 squared. Now, before we start solving, we do have some simplifying that does need to take place. Our 6x times x is going to be 6x squared. 6x times -1 is negative 6x. And 6 squared, 6 times 6 is 36. Questions on how we got to this point here? Do we have a variable with an exponent bigger than 1? You know, we have an x squared term. We have this higher degree polynomial function. So what it's telling me is we have to get this equation equal to 0 if we're going to solve. So we have to move the 36 from the right-hand side to the left. And since it's positive, we're going to subtract 36 from both sides. Questions on this here? Questions on anything we've done so far? Now, is there a number in common with all three terms? 6, yes? Well, on the last one, when we got down to solving, it had a 2 in common with all three terms, yes? Did that factor of 2 make any impact on the solutions once I pulled it out? Once we factored it out, it kind of sat at the front all the way through factoring, and then we just kind of threw it out once we actually started solving, yes? So could I have divided that 2 out and gotten rid of it? Yeah, because if I'd have just divided this by 2, this wouldn't have been there. We'd have done the exact same steps, yes? So here, we could factor that 6 out, or we can divide everything by 6. We can remove that greatest common factor. We can get rid of it. Because we're going to end up throwing it out anyways. If we're just factoring, we wanted it in factored form, we need that greatest common factor because it's a part of the factored solution or the factored form. Here, I don't care about factored form. I'm just wanting to find the values of x that's going to make that function equal 0. And that greatest common factor of 6, since it does not have a variable, we can get rid of it because it does not impact that part of the solution. Does that make sense? Well, clear all this out. Because at this point we have 6x squared minus 6x minus 36. And this is the graph of the function we're looking at, yes? And I just said that if we divide that 6 out, it will not change the solution because we have x squared minus x minus 6. Will it change almost every other part of the function? Yes. Because that red graph and blue graph are not exactly the same. There's only two spots where they are. And that's where it crosses the x-axis, the values of x that makes that function be 0. So for factored form, it makes a big difference. Those are two completely different functions. But for solving, it does not matter because the value of x that's going to make it be 0 are the same. Incidentally, it does cross the x-axis, yes? So if I go second table and we look for what values of x make the y value be 0, we're looking at -2 and 3. Questions on this here? Which of these two values do we think will not work? Probably -2. 3 is probably going to be the one that works. Log base 6 is 6 times -2 plus log base 6 of -2 minus 1. Because here I'd get log base 6 of -12. Really, at this point, we can say we're done. This is not going to work. Because I cannot take a logarithm of a negative number. I cannot have -12 inside the log. But if we kept going, yeah, we also have log base 6 of -3. That does not work. So x is not equal to -2. We have to throw it out. It's an extraneous solution. It is a solution we get from solving, but does not work in the original context. If I tried this with 3, we'd have log base 6 of 6 times 3 plus log base 6 of 3 minus 1. Log base 6 of 18 plus log base 6 of 2. Math. Log base 6 of 18 plus log base 6 of 2 does indeed equal 2. And mainly what we're checking is to make sure that what's inside both of these here is not negative. Questions on this here? Questions on anything we've done so far? Yes. If it doesn't, it's no solution. I mean, it could. And there is a chance that it could be both of them. And the funny one is when just based off the setup or the equation, the negative answer, like in the last one, -2 actually works, but 3 doesn't. It could be that too. Questions on these here? Questions on anything we've done so far? Yes. Yes. We're going to look at one more of these sums. Do we want to look at number 7 or number 8? So, log of 5x plus log of x minus 1 equals 2. And again, for us to be able to solve this, we need one log on one side, everything else on the other. So we can rewrite this as log of 5x times x minus 1 is equal to 2. Because again, we want one term on both sides. Since we have numbers outside the logs, we'll put them on one side. We'll put all of our logarithmic terms on the other. Now we're going to put both sides to the base of the log. And since it's not written, it's understood to be 10. So 10 to the log, really base 10, will simplify out, leaving us with 5x times x minus 1. The right-hand side does not simplify down. It doesn't reduce any farther than what it is, telling us that it is 10 squared. Five x times x is 5x squared. 5x times -1 is -5x. And our 10 squared is 100. And again, we do have an x squared term, so we're going to have to subtract 100 from both sides. Telling us that we have 5x squared minus 5x minus 100 is equal to 0. Questions on any of this so far? Questions on how we got to this point here? Now there is a greatest common factor of 5. So we can divide these constant terms out. We cannot do it with a variable. We cannot divide a variable out, because if I divide a variable out, we're removing a solution. Numbers, constants, it is fine. So if I remove that constant term, that scalar of 5 out, we get x squared minus x minus 20. At this point here, we can graph it or factor it. If we factor, we'd have 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. Factors of the first term, factors of x squared would be x and x, only factors. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. We'd want 4 and 5 because our middle term is -1. And I'm going to want that 5 to be negative because -5 plus 4 is indeed -1. Now at this point here, we do have two things multiplied together to equal 0. So one of these is going to have to equal 0. At this point here, our x plus 4, we would subtract 4 from both sides, telling us x is equal to negative 4. With our x minus 5, we would add 5 to both sides, telling us x is equal to 5. Log of 5 times negative 4 plus log of negative 4 minus 1 is supposed to equal 2. Here we get log of negative 20 plus log of negative 5. That's not going to equal 2, because even though our product property, if we used it, we get log of negative 20 times negative 5. Negative, negative, make a positive. 5 times 20 is 100. Would work, but I cannot do it because what's inside the log is negative. Log of 5 times 5 plus log of 5 minus 1. We'd have log of 25 plus log of 4. It does indeed equal 2. So it is our solution. Questions on this here? Now I'm going to go a little out of order. I want us to jump to the last problem before the homework. We're going to come back to the subtraction in a minute. I want to hit this one first. So I want to look at this one first. So it's at the very end, all the way at the back, right before the homework. Natural log of x plus natural log of x minus 5 equals 3. Now what we're doing is not changing. I have two natural logs. I have two logs with the same base being added together. So we do need to condense it. We do need to write this as a single log with what's inside being multiplied. So the natural log of x plus the natural log of x minus 5 is going to be the natural log of x times x minus 5. So that didn't change. That's still the same thing we've been doing. Now at this point here, to get those variables out of the logarithms, I need to put both sides to what base? E. Because the natural log's base is E. And E to the ln base E will simplify out, leaving me with x times x minus 5 is equal to e to the third. Now at this point here, some would say, I would disagree with them strongly, that we can round or approximate e to the third. Because if I wanted to see what e to the third is, it's 20.0855362. This is a irrational number. It has a non-repeating, non-terminating decimal. I disagree with rounding at this point because we're going to have to do more rounding later. Every time you round partway through a problem is the farther and farther removed we get from the actual answer. So we'll leave it as e to the third. Questions on this so far? Now we do need to solve for the value of x. So on the left-hand side, we're going to have to multiply out. And the reason is zero product doesn't work here. Even though I do have two or more things multiplied together, they do not equal 0. So we will have to distribute this x. X times x is x squared. X times negative 5, negative 5x. So now we have x squared minus 5x equals e to the third. We already saw that's 20 point massive long decimal. I do have an x squared term, yes? So I have to get this equation equal to 0. Well, not what I meant to write. So we're going to have to subtract e to the third from both sides, because e to the third minus e to the third, even though it is an irrational number, does give me 0. And by moving it over, we get x squared minus 5x minus e to the third is equal to 0. Yes? Now, we could try factoring it if we wanted to, but that would also require me knowing the factors of e to the third and seeing what factors of those will add together or combine to give me negative 5. And instead of doing that, we're going to use the quadratic formula. And this again is going back to our ax squared plus bx plus c. And for the problem that we have here, a is going to be the number in front of x squared. And what is our number in front of x squared? Well, there's not one written, so it's understood to be 1. What's the value of b? Negative 5. It's the number in front of x, yes? What would c be? Or negative e to the third. It's just the variable, or the, not variable, but it's the term without x. It could be a single number, but it's whatever's in that spot without x. A is the number in front of x squared, b is the number in front of x, c is the number without a variable. Doesn't matter what they are, it's just the numbers, those constants, those coefficients in those spots. So when we go to solve this, we're going to say x is equal to negative b. Well, that's fine. It's just negative 5. Plus or minus b squared. Well, that'd be negative 5 squared. Minus 4 times a. Well, a is 1 times c, which would be just negative e to the third. I'm just replacing a, b, and c with their corresponding values. And it's all over 2 times a, so 2 times 1. Questions on how we plugged a, b, c in for this here? Now we will need to simplify. Negative 5 is 5. On bottom, 2 times 1 is 2. Now up to this point, we would take everything inside the radical, plug it into the graphing calculator 30xs, and let it simplify it for us. But I know some of that's not going to simplify, at least to a nice number, because e is already irrational. It's going to give us a decimal, a not nice decimal. So we'll leave this here. Negative 5 squared, negative 5 times negative 5 is positive 25. What's negative 4 times 1? Negative 4. Now we're going to multiply negative 4 by negative e to the third. Well, that negative and negative would make a 4 e to the third. Questions on this here? And really, this is as simplified as we can take it or get it without turning it into a decimal approximation, because we're taking the square root, and we have e to the third, which is going to have to be approximated together. And really, we have 2 answers. And we're going to have to split them apart. I'm going to split them apart. plus. And the reason I say that, we split them apart and now we're going to get that decimal approximation, is because there is a chance that one of these does not work in the original context. So we're going to have to see which one it is. Now at this point here, I would grab either calculator. Fraction, 5 plus second square root. 25 plus 4 second, ln gives us e to the third all over 2. We can type it in as it is. And it tells us it's 7.632. Approximately. Not the exact value, but it is close enough for our purposes. Now we have to type the whole thing back in. We're going to say 5, but this time minus second square root. 25 plus 4 e to the third all over 2, which gives us negative 2.632. And most likely the negative 2.632 is the one we're going to have to throw out and get rid of. Because if we check it, the natural log of negative 2.632 plus natural log of negative 2.632 plus 5 is supposed to equal 3. Negative 2.632 plus 5, we can do that in a calculator. We can do it by hand. Either way works. 3. I can't take the natural log of negative 2.632. I can take the natural log of 2.368, but it doesn't matter. I can't take the natural log of the other term. So this is out, which means x is approximately 7.632. Thank you. No, that was a mistake. Should have still been 3, but it doesn't work either way. Questions on this here? Questions on any of this so far? But that's it. We'll stop there. I know we didn't get to the minus, but those aren't as crucial or as important. Also, 5 problems, 33 through 37. Yes. Thursday would be 662. Friday was a makeup day. You should get one solution for 33, 34, 35, 36. 35 and 36 are going to be approximations. Give me the... In a second, yes. You can give me, I will take the approximate and the quadratic formula expression of both of those. 38 will have 2 answers, or 37 will have 2 solutions.